Hello everyone, in this video we're going to be using Man in the Middle F to basically ARP spoof a certain device on your network. So this could be any device, it could be a phone, it could be a laptop, it could be a separate computer. And typically, well, in fact this would work in a public hotspot as well, and this could be used for like harvesting data, seeing what websites people are accessing, and also there's a possibility of actually harvesting sensitive data. So this video is for educational and ethical purposes only. It's for those that are interested in cybersecurity and ethical hacking and want to see how it actually works and how to defend themselves against it. So now that that's out the way, this video will basically, it's very similar to the previous video on my channel. Essentially we can basically track what websites people go onto, but SSL stripping is working in this example, so we can actually capture username and passwords for popular websites. This will work for your router at home. So say you're at your house now, you've got a brother or sister or friend, whatever, because typically in houses there's more than, I'd say now, about more than 3 devices. You'll be able to target one of them. So say it's your brother's laptop and he's in a different room accessing Facebook. You'll be able to basically target his laptop and gather all the information from his computer, such as what websites he's about to visit or going to visit, and also username and passwords that he enters on certain websites. That will work for his phone, your sister's laptop, even your parents, which always have permission to do so. So let them know that you are about to test it, if you don't have a spare device that you can test it on yourself. My target machine is going to be my host machine, Windows 10, as you can see here. My Kali machine is running on VMware, which is a virtual machine. And I've got USB wireless adapter connected to the virtual machine. Now the reason for that is, basically if you think of your LAN network, you've got your brothers, sisters, friends, computers, devices, such as phones connected to your router, and so are you. But because on your host machine, that is running the virtual machine. Now it doesn't have to be Windows 10, it could be a laptop running a virtual machine for Kali Linux. That needs to basically connect to the LAN network. And what I mean by that is, this is the best way I can explain it. When you create virtual machines, they create like a mini network of virtual machines within your LAN network. So what I mean by that is, if you see this virtual machine here, I've also got a Windows 10 one. Now if I just had wired connection only, then the only the only computer that I'd be able to target is this Windows 10 virtual machine, because they're in like the same network as each other. Now the way to like sort of break the Kali Linux away from that into the LAN network, which then can communicate to the other devices, is by having a USB wireless adapter. That USB wireless adapter will directly connect the Kali machine, which is a virtual machine, to the router itself. And that way we can target all the other devices on the network. So your other people's phones, computers, any device that basically connects to that router. So just to recap, make sure you have permission. So just whatever device you do target, make sure you do let them know that you are targeting it. And also, if you've got a device that you can test it on yourself, that you have permission for, and it's your own device, that's fine. So I think we're pretty much, that covers everything now, so we can get started. So head down to the description, click on the link. It's a GitHub repository for Man in the Middle F. All we need to do is git clone it, so copy this command right here. The commands will be in the description as well. Paste that into your terminal and click enter. Now it already exists for me, so once it's installed you can just go inside of this file and then type ls to actually display all the files within this folder. Now as you can see, it's a Python file, so you do need requirements. So if you copy this command from the description and paste it in, that will install the requirements. The requirements are basically dependencies that are required for the Python file to actually run. So if you don't have Python installed, for example, it would install Python, allowing you to run the Man in the Middle script. So that's Man in the Middle F basically installed. That's like, we're already 80% of the way there. The other thing is, if you're in a public hotspot and you want to capture data, for example, or you're in your house, like you keep saying, and you want to just basically target your brother's laptop, and the laptop itself is in a different room. So your brother's in his room, for example, or anywhere else. and you need to be able to find out what the internal IPv4 address is. Because if I go to my target machine, which is the Windows 10 host machine, if I type ipconfig here, as you can see, I know this is the right device that the host machine uses. This is the internal Wi-Fi card for the host machine. Because if I go down to the internet connection here, as you can see, it's Wi-Fi 2, so that matches there. As you can see, the internal IPv4 address is 11. So it's 192.168.0.11. That will be different for you. It might not be, but it might be. So don't worry if it is different. Just whatever it is, that's what the internal IPv4 address is of your target computer. But because I said before, it could be a friend's or brother's laptop that you want to target. You won't know what their internal IPv4 address is, because you can't go over to their laptop and open CMD or open like the terminal and type in ifconfig or ipconfig and find it out. So you can scan the network, you can scan the subnet. So what you can do is you can type nmap in a separate terminal, -h for the help, and at the bottom here it says nmap-v-sn. So what we want to use is nmap-sn. Then we want to just copy this bit here, only this bit. So then you type 192.168.0.0/16. Then all you need to do is click enter, and that will scan the subnet. And there we go. So if I stop that by pressing Ctrl and C, let's have a look now. So what we said the device was 11. So if we have a look here, this is the target device. Now the way Nmap displays it isn't very readable. So essentially it goes up in threes. So the IP address, this line here is always the start of the device. So as you can see here, this is a separate device. This is another one, and so on. And as you can see, this one here, that ends in 3, is an Apple device. Not sure what this is. That's on my LAN network, so I don't really know. Amazon Technologies, that's a Fire Stick. Netgear, that's like, actually I don't even know what that is either. But you get the idea. So you should be able to find the device through this way. Now there will be an article in the description of other ways of detecting devices on your LAN network, but that should do for now. Obviously you can go up to the person, because it's your brother or family member, whatever, and say to them, I'm testing this out, do I have permission? And you should get permission from it, and then you could just type it in on their computer. So if they've got a Windows 10 laptop, you could do exactly what I did before, ipconfig into CMD and find out their IPv4 address. But that's just something useful to know, so I'll type clear on that. Now the next thing is this command right here. I'll just get it up. There we go. That's just for speed, so I don't have to type it in. Essentially all you need to do to run the man in the middle script is python man in the middle f.py. The -i is for the interface. So I'm using WLAN 0, which is my wireless card. If I type ifconfig, as you can see here, WLAN 0 is my wireless card. ETH0 is the wired connection. But like I said before, we broke away from that using the USB wireless adapter. So I know it's WLAN 0. The spoof and ARP is basically just to spoof it with ARP. This HSTS is the SSL strip. The gateway is the gateway of the router. Now that is basically the IP address of the router, the internal IP address. So you type ARP-A in a terminal, and that's it right there. So it'll be the same for you. The IP address won't be the same, but it'll be in the same location in these brackets here. It might not be the same IP address though, so just paste it in there once you know what it is. Another way to check, if I go to the target computer and open up CMD, if I type ipconfig again, if I look, the default gateway is the same. So say it matches right here, and it matches down here. So I know that's definitely correct. The target IP address is what we've just discovered. Now I think it is 11, so I need to change that target IP address to 11. Let me just double check again. It does change a little bit, so let me just check. Yeah, it's 11. So this is correct now. So once I click enter, that will basically start the SSL strip, and it'll start poisoning the target computer. We'll start tracking it, and then we can try and investigate and see what websites get stripped and what information we can actually get. Another thing though is we want to actually track properly. So you can use URL snarf and just all you need to do is add the option for the interface. So WLAN 0. So now we've got our two terminals open, and all we need to do is click enter. So I'll start spoofing. There we go, man in the middle F will open. The SSL strip starts, and there we go. So I'll start URL snarf. Oops, sorry. I don't know why I've done that. It's -I WLAN 0. Click enter. So it's -I for the interface, and then WLAN 0. I don't know what I've done there. But there we go. So URL snarf's listening, and so is the poisoning. Well, the man in the middle F is actually doing its job. So let's go to our target computer, and let's see if it actually strips Google. So there we go. It stripped Google. As you can see, Google is no longer HTTPS, so it's not long. It basically not the information that gets sent to the website is not encrypted. So on a submission form for a login page, that information they submit, so your brother or family member or someone in public submits that information, sends it to Google. But what's happening is it's being sent to us first and then to the internet. So it's not encrypted. And as you can see down here, URL snarf's doing its job, so we can get an idea of what exactly they're going on to. So I can tell that the target computer's just got it onto Google, excuse me. So now we're on Google and it's stripped. Let's see what websites we can actually target. So let's try, I'm thinking of popular UK websites. Let's try Harrods. Harrods. It's a popular shop in London, very expensive. So let's just type Harrods, and as you can see, it looks like it's stripped. For some reason, you can't actually click on it. Let me refresh. The tutorial is basically over now. I know that sounds a bit weird, but all I'm going to be doing from this point is seeing what sort of information we can gather. So I recommend staying just to see what we can actually gather, such as username and passwords. I'm just trying different websites here. Let's try and go on Harrods. And let's open it in a new tab and see what happens. I'll redirect notice. So let's just go to Harrods. If Harrods doesn't load, we'll try another website. Harrods is just some shop. Let's try another popular shop in the UK, Tesco. Let's try and search Tesco. So there we go, Tesco. Try and click on that. Sometimes it doesn't actually work though when you click on it. See, I'm clicking on it now and it doesn't actually load the website. But when you open it in a tab, it seems to work. So let's just try and refresh Google. Let's try it again. Let's open it in a new tab. Go to Google, Tesco. Oh, so Tesco is stripped. It's just basically it's like a Walmart type shop. Right, let's see what information we could try and get. So sign in. So there is a login page, so we could possibly get information. Websecure.tesco. That's not very secure because there's no HTTPS, so it has stripped the HTTPS. But the website's not loading. So let's just give it a second because it does take time. This. Let's go back and try. Let's just go directly to a website, because if you type, for example, if I type Shopify here, it doesn't actually work if you like click on it. See, I'm clicking right now. I don't know if you can hear that, but it doesn't actually go onto the website. So I don't know if that's just like a bug or something. Maybe it's because it's been stripped. Let's try and open it that way. So there we go. We're opening Shopify. So Shopify seems to be loading and that's stripped. Tesco, it's stripped, but it doesn't seem to actually want to load the sign-in page. Now, I don't want to overload this because, as you can see, it's going a bit nuts in the background there. And the connection can drop. Oh, so Shopify is loaded. And as you can see, there's no HTTPS. I apologize because that might appear to be a bit small to see, but there's definitely no HTTPS here. I am using a browser which is Internet Explorer, which isn't very secure. So we will compare the difference between Internet Explorer and like Microsoft Edge. So Tesco WebSecure just doesn't seem to be loading. So let's try to go to the login page on Shopify. Oh, so Shopify is basically vulnerable here, as in the sense that if this was your brother trying to log into Shopify, someone in a public hotspot, you'll be able to capture the email and password for Shopify. Let's try and get an example of this. So Tesco definitely doesn't seem to be loading here. Let's try it one more time. It definitely is getting the website and it stripped it, but it just doesn't want to load. So Tesco's not working. Let's go to Google again. We'll try Shopify now, but let's try another website. We'll try Instagram. See what we can get from Instagram. So Instagram appears to be... Oh, wait, Google's gone back to being HTTPS. As you can see, Google was HTTPS then. There we go, it stripped it. So you can see it's not like 100% of the time, because that actually redirected to a HTTPS version of Google. I'm going to close this Tesco one now. I think it would work, it's just taking a while to load. You could tell the difference though, because Shopify loaded really quickly. So it is stripped, but I think it's just going to lag too much. So we'll go back to Google. Now it's stripped. Let's try Instagram. And as you can see, Instagram's now stripped here. But the clicking of it doesn't work still. So I think that's a bug. Oh, there we go. It's worked. So you can click on it. You just need to refresh the page. And Instagram is stripped. So again, we could imagine a situation where this is your friend or brother in your house on the local Wi-Fi, and they try and log into Instagram so you can capture their username and password. So they type my email at gmail.com and then my password. So let's imagine this is your brother on a separate laptop in a different room. You don't even know like what they're doing. You can't see them, but you can actually track them. So we know they're going to Instagram, as you can see down here, and we also will capture their username and password once they enter it. So let's have a look what happens. Click log in. There we go. Post data from Instagram.com. Username equals my email. Then the %40. The percentage sign 40 here, so let's just copy this so it doesn't keep jumping. What you can do is you can open a leaf pad and just paste it in. So let's just analyze this a little bit. So username equals my email, and this here, %40, is basically an @ symbol. So that is just essentially this. So I can replace that. My email at gmail.com. The password is equal to my password, which just said I entered. And there we go. So that's, for example, that could be someone in public. So you could call this accounts, and then just have like a list of accounts that you've captured. This could be a brother's or sister's Instagram account. So Instagram's basically compromised there on this local area network. Let's try another website. So let's go back on here. So we know Instagram can be stripped. Let's try Shopify now. So I need to just move this down. Let's try Shopify. So let's log in with, I'll try a different email now. So your brother's email. Well, excuse me. I'll just call it brother's email. And then brother's password. Let's see if I typed that correctly. Brother's password. So that's just to prove that we are actually capturing the right data and not sort of faking this. So I'll untick remember me, and let's just log in. Did we capture any data? Let's have a look. We got, oh no, that's Instagram. Shopify, oh, okay, Shopify doesn't appear to be working. Let's try it one more time, because I think it jumped. I can't see anything from Shopify here. So Shopify doesn't, oh, that's why. Right, okay. So this is a good example, actually. The connection's dropped. So this is why it's like 90% of the time, because the connection, if you're doing too much, it can just drop the connection. Because I think, to be honest, that's depending on what wireless USB adapter you have. It automatically does boot back up, so don't worry. Even though it keeps saying the network's down. I'm glad this happened though, because these are some of the problems you can encounter. So we'll just have to wait until it comes back up. There we go. So let's see if it gets the connection back again. Let's run URL snarf again. And let's see if we can refresh this. So can't reach this page. Let's try it again. There we go. So the internet's back up again when we're tracking it. So let's try it again. brothersemail@gmail.com and pass. So I'll just put pass for password so it doesn't. Oh, 5 characters. Okay. Password. So it's just password. Let's click login and see what happens. Let's see if we've got any data. Post data from Google. Nothing from Shopify. Oh, I see. I think that's why. Okay. So with Shopify, they have a verification. And obviously, their verification is sort of glitching it. So in a way, that's like a security thing, but it's not. They use captures for like bots, so you know, if like a DDoS attack happens, but obviously we're not being able to capture the data because it's not being posted, because you have to do the verification first. So I'm not sure if we'll pass this verification or not. I can't actually see if there's a car there. I think there is. Okay, this is difficult. There's a car there. Let's try and let's just click verify and see what happens. Please try again. So it's clearly not working. We'll try it one more time and then we'll try a different website. So we've got Instagram. We've got an Instagram account. We'll try Facebook next. I don't think that they must be cars. Verify. No, so clearly something's going on here. It's the capture. So we could capture the Spotify username and password, but we just have to hope the capture works. So let's just refresh. Just type anything, really, it doesn't matter, does it? So see if we get some data. No, it's still coming up with the capture. So that's a problem actually. So we can't really get Instagram data, Shopify data. See, the capture's coming up and it's all a bit glitched out. So Shopify, we'll have to leave that for now. If you really wanted like people's Shopify information or to harvest data from Shopify accounts, is the best thing you could do with Man in the Middle Earth is use DNS spoofing and basically get a clone of Shopify and run a DNS. So when they visit shopify.com, it redirects them to your local server, which is running a clone of Shopify. It'll, instead of presenting the actual Shopify website, it will present your clone from your local server. Once they log in, it'll send that data to your database or to a certain file. So Shopify does work, but it doesn't at the same time. So let's go back to Google. And let's try Facebook. I don't want to go, like, make this too long, but let's just see what websites we can get. So Facebook appears to be encrypted. Or with HTTPS, so I don't think Facebook's working. Let's go back and see. If I go to Facebook, let's try and just remove this HTTPS. So Facebook definitely is still encrypted. So that's where, like I said before, the 90% comes into it, because Facebook is definitely. Oh no, I tell a lie. If you look at Google, Google's not stripped. So let's try google.com again, see if it strips it. There we go, so it's stripped again. Now, you may be thinking, well, why would people just sit there refreshing Google? I would recommend, a lot of it's social engineering, because you could send them a link to just google.com by themselves, or you could just tell them to type google.com into their browser, and then they would be presented with the stripped version instead. Now, there's the odd chance, like before with the HTTPS version of Google, that might happen, so you might lose data there, but you can continuously run this and just capture as much data over many days as possible. It's a good, it's ethical. It's ethical in the sense that you can show people how it works, and then inform people to always make sure they're on a HTTPS version of the website. So let's just try Facebook again, see if this is stripped now. And there we go, Facebook is stripped. So let's just refresh again, because it's clearly not loading. Right, try it again. Click. as you can see, the click's not working again. It worked before with Shopify, so I think it's just a bug or something. Let's try it one more time. No, so we'll open it in a new tab. And we can't reach this page, so Google's gone down. I think has the internet gone down again? Let's try it one more time. I'll type Facebook and see what happens. So Facebook definitely goes to the HTTPS. I think that's why. I'll try and refresh it again, because Facebook would be a useful one to use, but you might have to use DNS spoofing with it because it's so secure. Because if I was able to actually click on it, in fact, what I'll do is, let's try Microsoft Edge for now. So let's go to Google. So Google is stripped on this one as well. Let's try Facebook on this. So Facebook stripped. Let's try and open it in a new tab. Facebook seems to be loading on this one. And there we go. So we're on a stripped Facebook. We can capture the information that they log in with. It doesn't seem to be working on Microsoft Explorer though, which is quite strange. Oh no, there we go. See, so it does work. It just takes a little bit of time. And obviously, if you wanted to capture people's, like your brothers or sisters or whatever's their login to Facebook, then you would have to send them this link here directly. I'd just say, oh, can you go on facebook.com? Because most people wouldn't realize that they're not using HTTPS, people who are not computer or interested in that in computer stuff. So they would think that's normal because it's still facebook.com. The odd chance it might work if they just click it directly through Google, because every time, because Google's stripped, it seems to have stripped basically every single website. So let's just get Facebook's information because we haven't captured much. So let's try Facebook email @gmail.com, Facebook password, login. We've got some post data. Is this it? This is the only problem. You've got to like look for the information itself. There's quite a lot of post data. Usually it's at the end. So it still appears to be encrypted. Let's have a look. Let's see what the website's saying. Social.facebook. What URL are we on here? What the fuck's this? Right, let's try it again. So Facebook email @gmail.com, my password, login. Right, we've just got a lot of information here, so it should be somewhere here. Now, forgive me if I miss it, because there's quite a bit of information on the page here. So there's post data here. Doesn't look like much in that. There's no post data here. There's quite a lot here though. What the fuck is this? Okay, it looks encrypted, but mouse movement. What the fuck is this? Right. Okay. Oh, is that it? Is this it? There we go. I fucking found it. Yes. So, see, that's a negative, I suppose, of man in the middle F. Now, because it's a Python script, I'm quite familiar with Python, and I like Bettercap better because of the format. Apart from the SSL stripping, that doesn't work. As you can see, the email and password is right here, what I've just typed in. So, what I was saying before about Bettercap is that I'm trying to create a script that will incorporate both. I'm not going to copy them, I'm going to try and develop it myself, but essentially it will take the best bits of like most common scripts and just put them into one, because man in the middle F isn't very readable. So we've got Facebook email, even though I didn't type that right. Let's see if we can. Did we capture the first one we sent though? Because it changed the URL, which is quite strange. Still got Facebook here. I'm just looking to see if we did capture the first email we typed in, just in case I missed it, because it should have captured it. User, and that looks encrypted. Don't know what the fuck that is. Right, so you can capture Facebook then. I think you might have to redirect them though to this URL, so social.facebook.com. Let's try it on the this URL again. So Facebook email, I'll put new in the email and password again. Right, let's make sure we can try and capture this. So what I'll do is I'll move this over down here. I'll click login and see what jumps. Right, okay, that was a bit too quick, but whatever. Right, shit. Ah, there we go. So it did capture it. I'm just fucking blind. It's right there. So as you can see, new. So we can capture Instagram, Facebook through this poison. Let's try. Shopify did work, but it didn't. There must be another login feature somewhere. Let's go back to Google. What other websites? Because this is quite a long video now, but like I said before, the tutorial ended ages ago. You could go and mess about with this yourself, but I'm just showing you examples now of what websites and seeing what websites we can actually strip and get information from. So Twitter, let's try Twitter. We'll try Twitter as the last one. Twitter looks stripped at this point. See that? Clicking's not worked. So let's try refreshing. Error. Okay, refresh it again. Okay, it seems to be, the click on Google seems to be broken. See, I'm clicking now and it doesn't actually send it to the website. So that's a bit strange. Because if someone like your brother's searching on Google, then that's not a good idea. Maybe they might be clever enough to right click and open it in a new tab. But I'll see if I can get that working. So let's just refresh it one more time. No, it's definitely not working there. And the reason I got two browsers open, in fact, was to show you that it does work on like even a more up-to-date browser. Internet Explorer is shit, but Microsoft Edge is better. So let's just open this in a tab. Let's see what happens. Oh, what the fuck's just don't know what the fuck's just opened there. Right, okay, what the fuck. Right, let's just type Twitter and see what happens. Twitter.com. So that's encrypted, but maybe if we copy this URL here, it's not. So let's see this. Let's just paste this in here. Web Twitter. What the fuck's web Twitter? Right. Okay. This seems to be unencrypted. So let's just see if we actually get information from a login. So my Twitter email at gmail.com. It's very unlikely people would sign in like this, but let's just see. Because if you send someone that link, I'm sure they'd log in. Twitter pass. I don't know if I typed that correctly, but I'm not bothered. So log in, and we did, as you can see right there. So my Twitter email. So Twitter is vulnerable in the sense that they've got a unencrypted webtwitter.com URL sign in. Oh, there we go. There's a better link to give people. So it's, if I remove that, it's webtwitter.com/login. As you can see, there's no HTTPS, and we can capture the username and password. My shitty email at gmail.com. So let's log in, and do we get that information? There we go. So Twitter, so we've got Facebook, Twitter, we basically got Shopify. I'll have to have another look at that. Facebook, so basically all the websites. This SSL strip is very, very, it's very reliable, in fact, because I'm quite surprised, even on a top browser. Let's think of one last website, because this is a very long video, but I tried Harrods before, but that didn't work. Let's try it one more time for luck. It's a very, oh, there we go, the click worked first time. Oh, I guess I am lucky then. So let's just see if it loads. So let's say this is your brother going on Harrods, or your sister, and you want to get their login for some reason. It would make more sense in a public hotspot. So someone tries to go on Harrods and go shopping with their credit card information. This is not good, because then you'll be able to capture all their credit card information and their username and password, so you can go shopping. You can go shopping yourself. So Harrods does seem to take a while to load. I think it's just because it's such a large website, and I mean, it has got a lot of information on Harrods. I'm trying to think of another popular like shop, maybe. Let's just try a shop, online shop. ASOS. I've heard people shop on that. So ASOS seems to be stripped, so let's just open this. So you send your brother that link or his sister that link to go on ASOS and sign in, and you get the username and password. So it seems to be loading. There we go. Can we sign in? Where can we sign in? Here. Let's see what happens. Oh, it did go to a HTTPS link, as you can see up here. Let's just try and remove that and see if it gets stripped. Right, okay, so that does appear to be secure. ASOS sign in. Let's just see what happens when we Bing that. Bing's secured. So let's go back to Google. That's stripped and type ASOS login. So ASOS doesn't seem to be able to get stripped. If that happens, just refresh it. Log on. What the fuck's log on? Okay, just open this. Marketplace.asos.com. Right, okay, it is stripped. Don't know what the fuck we logged into before. This is the marketplace, though. I don't know what the fuck this is. I don't know if this is the actual shop itself. Let's have a look. There's a sign-in page here, so let's have a look at both of these. Okay, that just won't open at all. Let's try it one more time. Let's copy the link and see where it's sending us. So copy link. Let's just see where this is sending us. What the fuck is this? Source asos.com. No, it is sending to the same place. So I guess the marketplace is just like a subdomain, but let's see if we can get this information. So ASOS login. I don't know anything about ASOS, so I don't know if I'm signing into the actual website here or what. So ASOS login password. Sign in, and we got it. As you can see, right there. But it's, oh god, I can't even use this. What the fuck? So as you can see it there, login password equals asoslogin@gmail.com. So ASOS is, I suppose it is compromised in this sense. I don't know about the actual ASOS website though, because if I go to ASOS here, the ASOS website is stripped, the main one, but when you try and log in, you go to the sign-in page. That is definitely secure. So if I copy the link to that and paste it in here, say permission denied, so, or access denied, so it's definitely secure. I don't know why that is actually secure, but you never know. Let's try and remove it. Remove that as well, so it doesn't do any of that. So ASOS seems to be secure. But it's also not secure because the marketplace one isn't, so I don't know if that's useful to anyone. I don't know ASOS. It's just a random website. We've got 3 minutes left, so we'll do another website. I'll leave this a 40-minute video. So we've got Twitter, Facebook, Instagram. We've got all the main websites really, but we need more. Let's try a bank. I don't know if a bank would work. I don't know if this is getting a bit dodgy as well. So let's just try NatWest. This is a bank in UK. Let's just see if this is stripped. Now, I've got to mention now that this doesn't affect the actual website. So nothing illegal is actually happening to their website. Their websites are still secure. As you can see, if you type HTTPS in the front of that, it will send you to the HTTPS version. The only thing that's being stripped is the HTTPS from the websites that the devices are being presented with. So NatWest seems to be stripped. So basically we'll get banking information here. Let's just see if we get the customer number. So let's just type a random customer number in. I don't know how long it is. Did we get any sort of information from that? Card number, let's try that. So 16 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7. Right, continue. Card isn't recognized. Maybe it's not actually posting it then. So it is stripped, but I think it's still secure. So let's just have a look. There's nothing from post data from yeah, this bank. Let's just click login and see what happens. cookie check. So it's sort of a login, but it's a bit strange. So 10:53 88 102. So did we get any sort of information from that? Let's have a look. So it did post it then. So this bank did post the information. Card, customer number. So it did. So basically we're getting a banking information from basically the device that you target. So if this was like a public hotspot and they went on this website and tried to sign in, you would get their customer number, their PIN, or their card number. So that is stripped. I'm assuming basically pretty much every website is stripped. That through the Google, that is stripped, if that makes sense. So if you type any website in here, that will be stripped. If I scroll down, as you can see, Gmail is stripped here. So I'm going to leave it there. I know it's a long video, but hang on, what's this? Oh, never mind. I thought that was another website then. I don't know what that was. Anyway, it's a long video. I apologize about that. It was an interesting video finding out what information we can get. But I'll leave it there for now. So if this video did help or it was interesting, please leave a like, comment if you're stuck with anything. I'll be happy to help. Subscribe for future content, and I will see you all in the next video.